Hello my friends and welcome back to the You Can Do TV channel. The fast-foot footing system offers a modern alternative to convene 2x4s instead of heavy 2x10s. The system is lighter, easier to carry, and quicker to strip after pouring. The fabric bag design eliminates gaps, keeping the footing sealed and preventing concrete loss. In this project, the crew poured 80 meters in just 3 hours, with a 100mm slump mix, showcasing the system's productivity. The fast-foot fabric creates a strong, clean form, and when properly installed, its overlap shear strength supports significant loads. Experienced builders note its user-friendly nature, reduced labor strain, and reliability compared to traditional wood forms. This makes it a preferred choice for efficient, high-quality footing construction. In the 140,000 square foot warehouse expansion in Kitimat, BC, Fastfoot was used to form 145 concrete footings for a steel structure with aluminum cladding. Each footing was designed for wind and seismic loads, with vertical steel reinforcements extending from the pads. Fastfoot was installed on 2x8 screed boards using 3/8 staples. For the 137 standard pads, 20 x 10 minus 5 inches x 20 inches, a single top rail set the final concrete height, simplifying screeding. Unlike plywood forms, Fastfoot reduces lateral pressure by up to 50%, lowering bracing needs and labor. A 14-pound roll of Fastfoot replaces 900 pounds of plywood and remains in place, cutting stripping, cleanup, and material handling, ideal for large-scale concrete work. Hondejo. Lear Duracol elements offer a modern, eco-conscious solution for wall construction. Made from wood cement composite, these innovative blocks combine the strength of concrete with the natural benefits of wood fiber. The result is a lightweight yet highly durable material that delivers outstanding thermal and acoustic insulation. Designed for quick and efficient assembly, Duracol blocks simplify the construction process, reducing labor time while improving building performance. Their excellent breathability and moisture regulation contribute to a healthier indoor environment, making them ideal for both residential and commercial projects. The hollow core structure allows for reinforced concrete filling, enhancing structural integrity without sacrificing sustainability. Manufactured with natural, recycled materials, layered Duracol supports green building standards and long-term energy savings. Whether used for load-bearing walls, partitions, or energy-efficient facades, these elements bring versatility, performance, and ecological value to every project. Forming an ICF, insulated concrete form, basement in just 5 hours is achievable with proper planning, tools, and teamwork. The process begins with a level and compacted gravel base. ICF blocks, lightweight, interlocking panels made of expanded polystyrene, are laid out and snapped together like building blocks to form the basement walls. Vertical and horizontal rebar are placed inside the block cavities according to structural plans, providing reinforcement before the concrete pour. Corners, T-junctions, and openings for windows and doors are braced using special accessories or custom-cut blocks. Temporary bracing and alignment systems are installed to keep the walls plumb and secure during the pour. Concrete is then pumped into the forms and lifts, ensuring an even distribution and avoiding pressure buildup. With a coordinated crew and quality materials, the ICF system offers a fast, energy-efficient, and durable solution for building full basement foundations. While 11 days, more than 300 volunteers in Oradea took part in constructing a Habitat for Humanity duplex using the Planzoo modular floor system, a highly efficient, prefabricated composite solution combining reinforced concrete ribs, ceramic infill blocks, and a final concrete overlay. This system enabled fast, precise installation with reduced labor intensity and high safety standards, making it ideally suited for an intensive, volunteer-led housing project. Preparation began with thorough leveling of all bearing walls. Wooden support beams, 5 x 10 centimeters, were placed on edge atop the walls, supported intermittently by adjustable metal props spaced approximately 1.2 to 1.3 meters apart. The supports were deliberately raised 3 centimeters above the existing wall level to accommodate placement tolerances. For spans exceeding 1.65 meters, supplemental beams or telescopic supports introduced a slight camber of around 1 to 2 centimeters to offset potential deflection once the concrete was poured, ensuring a level finished surface. Once the temporary support grid was in place and aligned precisely, the modular floor system elements were installed. Prefabricated reinforced concrete ribs were first laid across the span. These ribs, engineered for strength and precision, were aligned parallel and embedded at least 5 centimeters into the supporting walls, while protruding 3 centimeters above the support surface to guide assembly. Lightweight. Between September 9th and 20, more than 300 volunteers in Oradea took part in constructing a Habitat for Humanity duplex using the Planzoo modular floor system, a highly efficient, prefabricated composite solution combining reinforced concrete ribs, ceramic infill blocks, and a final concrete overlay. This system enabled fast, precise installation with reduced labor intensity and high safety standards, making it ideally suited for an intensive volunteer-led housing project. Following precise rib and block placement, a welded steel reinforcement mesh, typically composed of 4 to 6 mm diameter rods arranged in a 100 x 100 mm grid, was laid over the entire floor field, extending beyond ribs and over support beams. Mesh overlaps of at least 15 centimeters ensured structural continuity, and plastic spacers maintained proper clearance from the ceramic layer to ensure concrete cover and long-term durability. In higher load zones or mid-spans, additional longitudinal reinforcement bars were incorporated to bolster structural integrity. This methodical modular approach allowed volunteers, many lacking construction experience, to meaningfully participate under professional supervision. Structured guidance enabled safe involvement in each phase: leveling and supports, rib and block placement, mesh installation, and final pour. The clear sequence and why with volunteer engagement. Beyond its technical merits, Planzoo enabled rapid occupancy potential. Structurally stable, thermally performant floors without formwork, minimal cleanup, and reduced labor demands. The experience demonstrated architecture's ability to catalyze community empowerment, where volunteers gained hands-on construction knowledge while contributing tangible value to housing infrastructure. Safety remained a top priority throughout the build. With over 300 volunteers working in coordinated shifts, strict safety protocols were enforced. Hard hats, gloves, vests, and protective eyewear were provided, and dedicated safety officers monitored each zone of activity. By using prefabricated components and eliminating the need for formwork erection or dismantling, the risk of work-at-height injuries and exposure to sharp formwork edges was significantly reduced. Before commencing the concrete pour, the entire surface, particularly the ceramic blocks and ribs, was lightly wetted to promote adhesion and minimize water absorption from the concrete mix, ensuring a robust monolithic bond. Concrete classified at C18/22.5 or C20/25 B300 strength with a maximum aggregate size of 16 millimeters was poured in a phased pattern. First, perimeter belts were placed to act as containers, followed by filling between ribs and finishing with the overlay, maintaining a topping thickness of at least 6 centimeters above the ceramics. Continuous pouring was encouraged to avoid cold joints, and mechanical vibrators ensured thorough compaction and surface consistency. Once the concrete was uniformly screeded to a smooth finish, curing began. The surface was covered with protective sheeting and kept moist for 7 to 10 days. The temporary supports remained until completion of a 28-day curing cycle, ensuring the slab achieved design strength before support removal. Once the concrete had cured and temporary props were removed, the floor slab served as a stable, load-bearing surface, ready for the next phase of construction. Roof framing, partition wall installation, and facade works could begin immediately, demonstrating the speed and efficiency with which the Planzoo system integrates into broader construction schedules. This project serves as a model for scalable, inclusive construction solutions worldwide, especially for social housing, post-disaster rebuilds, or rapid infrastructure deployment. Planzoo offers an accessible, high-performance system, engineered precision with modular simplicity, built efficiently, sustainably, and collaboratively. Structowire Corporation is a leading manufacturer of engineered stucco reinforcement products designed to enhance stucco performance, job site efficiency, and installer safety. Produced on high-performance machinery, Structolath features a patented cold-rolled flat wire that increases tensile strength while reducing curvature memory, ensuring each roll lays flat and remains flat for precise installation. Structa's twin-track lath system offers superior coverage, with one roll replacing up to 25 sheets of traditional lath. Each roll is lightweight, easy to cut, and bends cleanly around corners. The 6.5-inch spaced twin tracks provide consistent attachment points for screws, nails, or staples. With a minimum one mesh overlap, panels nest together seamlessly, preventing stucco buildup and minimizing cracking, resulting in over 60% crack reduction in finished walls. Easy to cut, easy around corners, worker-friendly product, minimizing injuries during operation, simple installation. Just fix the mesh to the wall surface, then spray concrete or plaster directly. With perfect construction ability, high crack resistance, Structowire is now widely trusted in commercial and civil projects, providing a strong, aesthetic, and durable concrete coating. Insulating an entire house in just one day may sound ambitious, but with Ecotermix spray polyurethane foam (SPF), this goal becomes entirely achievable. Designed for maximum efficiency and thermal performance, Ecotermix outperforms traditional insulation materials such as mineral wool, expanded polystyrene (EPS), and cellulose across every key performance metric. Ecotermix uses a two-component system, polyol and isocyanate, that reacts on contact to expand rapidly into a dense, closed-cell foam. Upon application, the foam expands up to 60 times its liquid volume, instantly filling voids, cracks, and hard-to-reach spaces in walls, floors, ceilings, and roof cavities. This expansion creates a continuous, joint-free thermal insulation layer with no cold bridges, ensuring total building envelope protection. Unlike mineral wool or EPS, which often require cutting, fitting, and mechanical fastening, Ecotermix is spray applied directly onto the substrate, adhering tightly to any surface, wood, concrete, brick, or metal. This means installation time is dramatically reduced, while insulation quality and coverage are significantly improved. In fact, with professional spray rigs and trained installers, a 150 to 200 square meters home can be fully insulated in just a single working day. From a thermal perspective, Ecotermix boasts higher R values per inch compared to most conventional materials. It provides excellent resistance to heat transfer, ensuring that interior temperatures remain stable across seasons. This helps reduce reliance on HVAC systems, leading to up to 50% savings on heating and cooling energy bills. In addition, the foam's closed-cell structure acts as an effective vapor and air barrier, eliminating the need for multiple separate layers and reducing material costs. Moisture protection is another key advantage. Because Ecotermix forms a water-resistant barrier, it prevents condensation and water ingress, common issues that lead to mold, rot, and insulation degradation in other systems. The foam also contributes to the structural integrity of the building, thanks to its rigid form and strong adhesion, especially in wall cavities and roof assemblies. Ecotermix insulation is also known for its health and comfort benefits. The airtight seal prevents outdoor allergens, dust, and pollutants from entering the building, creating a cleaner indoor environment. Furthermore, the material dampens airborne noise, enhancing acoustic comfort throughout the house. Durability is equally important. Unlike cellulose, which settles over time, or fiberglass, which can sag and lose efficiency, Ecotermix maintains its shape and performance for decades. Once installed, it requires no maintenance, no replacement, and no adjustments, delivering long-term value and peace of mind. In summary, Ecotermix spray foam insulation offers a fast, effective, and superior alternative to traditional insulation materials. It combines high thermal performance, air and moisture sealing, quick installation, and long-lasting durability into a single, all-in-one system. Whether used for new construction or energy-efficient retrofitting, Ecotermix provides a complete insulation solution, professionally applied and fully functional, in just one day. The Lear model house is being built with high-quality solutions, including Roto premium roof windows equipped with factory-installed thermal insulation packages for outstanding energy efficiency. 3 different opening types of roof windows and a side-hinged roof access window have been installed. The Roto Designo series offers refined aesthetics combined with high performance. Whether using double glazing UW 1.1 or passive house standard triple glazing UW 0.8. Roto windows are available in wood or plastic and can be paired with external shutters or thermal blinds with manual or electric operation. Beyond energy savings, these windows are engineered to adapt to roof structure movements, allowing for easy post-installation adjustments. Due to the above-rafter insulation system used on this roof, a special installation method was required. A rigid polystyrene-like frame element known as MDA was embedded to form a thermal bridge-free connection. The windows were carefully sealed using specialized tapes and tools. With both roof windows and side opening access units installed, complete with optional sun protection accessories, the Lear model house showcases modern roofing done right. Every durable roof begins with a carefully executed system of drainage, sealing, and structural alignment. The Roofart umbrella metal tile system, known for its concealed screw fastening and modular panels, showcases a comprehensive approach to roofing. Starting from gutter installation and ending with a perfectly sealed, aesthetically seamless roof. The installation process begins with the assembly of the pluvial system, which includes gutters and downspouts. These components are mounted securely along the roof edges using robust metal brackets. Precision is critical at this stage to ensure proper slope for water flow. The gutters are aligned with a gentle pitch to facilitate drainage toward the downspouts, which are attached vertically along the facade, channeling rainwater safely away from the building's foundation. Roofart components are engineered for quick coupling and leak-proof performance, forming the first line of defense against water intrusion. Once the drainage system is in place, attention shifts to waterproofing the structure beneath the metal tiles. A combination of underlayment membranes and sealing tapes is installed directly on the roof deck. These layers prevent moisture infiltration and act as a barrier against condensation. In valleys, around openings, and at panel overlaps, additional adhesive flashing materials are applied to reinforce critical zones. With the waterproofing layers installed, the process continues with detailed measurements and marking. Technicians ensure that the roof's geometry, angles, ridgelines, and eaves aligns precisely with the modular layout of the umbrella panels. Accuracy in this step determines the uniformity of the finished roof. Reference lines are marked using chalk or laser levels to guide panel placement from the bottom up. Next comes the preparation and assembly of corners, ridges, and detailing around obstructions. For areas such as chimneys, dormers, or ventilation pipes, customized flashing elements are cut and fitted on site. These flashings are sealed to both the waterproofing membrane and the tile surface to ensure complete protection. At the roof's edge, corner profiles and ridge caps are installed to close off the structure and allow for thermal expansion of the panels. The heart of the system lies in the installation of the umbrella metal tiles, characterized by small format panels with hidden screws. Each panel interlocks with the adjacent one, with fasteners inserted into concealed channels that become covered as the next panel is placed. This technique eliminates visible screw heads, enhancing both the visual appeal and weather resistance of the roof. Installers begin from the eaves, securing the first row of tiles along the lower edge of the roof. Panels are carefully placed and adjusted to align with the reference lines. Once aligned, screws are inserted using torque-controlled drills to avoid over-tightening. The process continues upward, row by row, maintaining uniform spacing and tight interlocks between panels. At every step, measuring and trimming are required to fit panels precisely around architectural features or at the edges of the roof. Metal shears or cutting tools are used to adapt panels without compromising their structure or coating. Around chimneys or vent stacks, flexible flashing elements are installed first, followed by cut-to-fit tiles sealed against the flashing, using special sealants and mechanical clamps. Ridge elements are installed last, covering the junction of the two roof slopes. These are vented when required to allow airflow beneath the panels, critical for reducing condensation and prolonging the life of the roof system. These ridge caps are also fastened with hidden screws and sealed with weather-resistant gaskets. The result is a fully integrated roofing system, structurally secure, watertight, and visually harmonious. Thanks to the small panel format, installation is fast and flexible, even for complex roofs. Two skilled professionals can complete an entire house roof safely and efficiently, without requiring heavy equipment. From a performance standpoint, the combination of corrosion-resistant metal, hidden fasteners, and advanced drainage ensures long-term protection from wind, rain, snow, and UV exposure. From an aesthetic perspective, the roof appears monolithic, no visible overlaps, no exposed fasteners, and a sleek tile texture that complements any architectural style. In conclusion, the Roofart umbrella metal tile system represents an evolution in residential roofing. By starting with a robust rainwater system and following through with expert waterproofing, precise measurement, detailed edge finishing, and concealed screw tile installation, the result is a roof that's built to perform and designed to impress. Wow! The Stoofix brick slip cladding system offers a fast, durable, and aesthetically consistent solution for modern facades. Prefabricated and pre-mortared panels are manufactured in controlled factory conditions, ensuring uniform quality and performance. Each panel is mounted onto a customized modular fixing system, which can be attached to any load-bearing structure capable of supporting approximately 40 kilograms per square meter. Various insulation materials can be integrated into the system, providing flexibility in thermal design. Installation on site is efficient. Panels arrive ready to mount, eliminating the need to individually fix each brick slip. Once secured, joints are grouted to create a finished, seamless brick surface. Designed for speed and accuracy, the Stoofix system reduces labor time and site disruption while delivering the look and feel of traditional brickwork. It is ideal for both new construction and renovation projects requiring high-quality, ventilated brick facades. Bringing daylight indoors has never been simpler. The solar tunnel offers a clean, efficient solution for natural lighting, installed in just a few easy steps. The solar tunnel represents a new way to capture and redirect sunlight indoors. As renewable energy solutions continue to evolve, solar tubes stand out for their practicality, reliability, and ability to meet basic human lighting needs. Naturally. Enjoy the benefits of clean daylight. Anytime, anywhere. The process starts with the preparation of the solar tube, followed by the connection of the collector to the tube, creating the path through which sunlight is captured and directed. Next, the base is installed. In this installation, a flat base was used on a conventional brick structure. However, it can also be mounted directly on a sloped roof using a pitched roof base. With the base secured, the tube is introduced through a standard inclined roof tile. Once in place, the protective film inside the tube is removed, exposing the highly reflective inner surface designed to optimize light transmission. And it's ready. Natural light now fills the space below without electricity, without wiring, and without complications. From rooftop to interior, the installation is designed for simplicity and durability. Ideal for both residential and commercial settings, this system enhances interior lighting while contributing to energy savings and environmental responsibility. Lear chimney systems are engineered to meet the demands of modern heating technologies, offering safe, durable, and energy-efficient solutions for residential and commercial buildings. Designed for use with solid, liquid, and gas fuels, Lear chimneys provide exceptional versatility and adaptability across various heating applications. Each system is composed of high-quality components, including thermally insulated ceramic flue liners, lightweight concrete outer blocks, and efficient ventilation channels. This ensures optimal draft performance, excellent heat resistance, and long-term structural integrity, even under extreme operating conditions. Thanks to modular construction, layered chimneys allow for quick and precise installation, reducing time on site while maintaining the highest standards of safety and functionality. Their triple-layer design also enhances condensation resistance and minimizes thermal bridges, supporting efficient energy use. These systems offer high mechanical strength and abrasion resistance, properties that contribute significantly to their longevity. In addition, the ceramic pipes are eco-friendly and recyclable, supporting sustainable construction practices. Certified to meet strict European standards, layer chimney systems represent a dependable choice for builders and homeowners seeking future-ready heating infrastructure. Patterson Shoring is a structural elevation contractor specializing in load distribution, subgrade stabilization, and foundation remediation. Utilizing synchronized hydraulic jacking systems, the company executes uniform elevation of residential and historic structures with millimeter precision. Each lift is engineered based on structural load paths, soil conditions, and lateral stability requirements. Reinforcement methods include helical pile systems, steel underbeams, and modular cribbing arrays. Patterson's process mitigates shear stress, preserves architectural integrity, and ensures compliance with FEMA floodplain elevation standards. Time-lapse documentation highlights the controlled ascent sequence and mechanical synchronization across all lifting points. The firm's technical capabilities are backed by certified crews and a proven safety record. This showcases the application of EPI Level Mix, an industrial epoxy resin leveling screed by Luber. It starts with mixing HEPA level liquids with SiL, then gradually adding EPI level powder using a high-torque drill and paddle. The mixture is poured onto a primed surface and spread to a thickness of 2 to 3 millimeters using a steel trowel. A spiked roller removes air bubbles, ensuring a smooth, seamless finish. Once cured, the epoxy screed provides a high-strength, hygienic surface ideal for industrial settings, requiring durability, chemical resistance, and a glossy, dust-free appearance. Resin-bound surfacing is a fast-growing driveway and landscaping solution, offering both style and performance. Fully permeable and SUDS compliant, it allows water to drain quickly through the surface, helping to reduce flooding, river pollution, and pressure on drainage systems. In this project, the existing block paving was removed due to subsidence and weed growth. A permeable subbase of hardcore was prepared, topped with the VUBA cellular grid for stability and drainage. Resin-bound systems can also overlay existing hard surfaces, like concrete or tarmac, offering flexibility in installation. On-site, the chosen aggregate and premium-grade resin, manufactured by VUBA in East Yorkshire, were mixed and hand-applied for a seamless, durable finish. With aggregates sourced from leading quarries worldwide, the result is a beautiful, low-maintenance surface with a 15-year warranty, enhancing curb appeal while eliminating common driveway issues. Home. Dorado EZ column wrap by Ply Gemstone offers a fast, clean, and professional-grade solution for transforming standard posts into elegant masonry-style columns. Designed for simple mechanical fastening without mortar or wire mesh, this system enables a 4-foot column installation in just 10 to 15 minutes. Each wrap is made of lightweight, durable stone veneer in modular 1-foot sections, designed to fit standard 4 inches x 4 or 6 inches x 6 posts. With the interior foam removed, it can also accommodate 8 inches x 8 posts. Sections fasten with screws at designated anchor points, eliminating mess and reducing installation time. Once aligned and leveled, a high-strength construction adhesive secures each piece. Installation requires minimal tools, a level, screw gun, and caulk gun. Ideal for both professionals and DIY users, the system installs best on a concrete pad or compacted stone base. To finish, a 2-piece cap is provided in 3 color options: charcoal, lime, and brown. Each cap is pre-sized to fit tightly over the completed column for a clean architectural finish. Dorado EZ column wrap blends aesthetics with efficiency, making it an ideal solution for enhancing decks, patios, or entryways. Inject 2133 is a 1-component, phthalate-free polyurethane injection resin designed for fast and effective sealing of water-bearing cracks in concrete structures and excavation pits. It is engineered to expand up to 60 times its original volume, enabling it to rapidly stop pressurized water flow and seal gaps with long-lasting results. This ready-to-use resin requires no mixing and features unlimited pot life, allowing for flexible, time-efficient application. Simply drill into the crack, insert the injection packer, and inject the resin. The material reacts immediately with water, forming a dense closed-cell foam that blocks further ingress. Inject 2133 is not only highly efficient, but also safe and hygienic, containing no harmful phthalates. Its performance has made it an ideal solution for emergency waterproofing, crack sealing, and joint protection in basements, tunnels, retaining walls, and concrete joints subject to movement or water pressure. This system reduces labor, saves material, and provides reliable sealing performance in even the most demanding wet conditions. The Cobra flexible profiles by IPRO FILISRL revolutionized the way curved plasterboard walls and ceilings are built. Engineered for ease and precision, these innovative metal tracks can be bent manually by hand, eliminating the need for specialized tools or machinery. Ideal for both professionals and DIY enthusiasts, the system simplifies the process of creating smooth, flowing architectural curves in residential or commercial interiors. The range includes several key components designed for different applications. Cobra flexible tracks are suited for general curved surfaces. CONCAV profiles are perfect for inward-facing curves, while convex profiles are ideal for outward bends. The VARIANGLE serves as the starting point for curved ceiling structures, ensuring alignment and strength from the base up. Made from durable metal and designed with flexibility in mind, these profiles ensure consistent, high-quality results. They allow for faster, cleaner installation, reducing labor time and ensuring a flawless finish. With IPROFILI's flexible profiles, creating curved plasterboard features has never been easier or more accessible, combining innovation with practical functionality. In a shaft near Toronto, Earth Boring successfully conducted their first soil consolidation using Inject GL95, a highly flowable acrylic gel ideal for fine porous soils. The two-component, air-driven pump system and deep penetrating injection lances allowed efficient gel distribution within the soil. Inject GL95's flexibility, swelling capacity, and strong sealing performance make it ideal for underground infrastructure and tunneling. This marks a successful application of advanced acrylic injection technology in Canada, already proven globally across complex sealing and soil stabilization projects. What if a luxurious swimming pool could rise from the ground in just a matter of days? Precision built from prefabricated panels, engineered fittings, and a system so refined that every component clicks seamlessly into place? Hidden behind the elegance of shimmering water and clean lines lies a remarkable construction process. The following describes the step-by-step process of assembling this pre-engineered system, ensuring structural integrity and long-term performance. Site preparation begins with earthworks. Excavation is carried out according to the pool kit's specific dimensions and depth requirements. Precision in this phase is critical to ensure a stable foundation. The base of the excavation must be leveled and compacted thoroughly to support the concrete slab and wall panels. A concrete base slab is then poured. This slab must cure for a minimum of 7 days before the next phase begins. Curing time ensures the structural stability needed for wall installation. Following the slab cure period, the pool structure is assembled. Steel or polymer panels, along with corner modules, are positioned along the trench perimeter. Each panel is aligned carefully, with special attention to the square holes on the flanges, which must match with adjacent panels. Support feet are inserted laterally from right to left to slightly expand the panel joint and allow for the insertion of locking pins. Once secured, the upper edges of the panels automatically align. This method is applied consistently for all panels to form a continuous perimeter. A final check is conducted to verify alignment and ensure that the wall layout matches the pool blueprint precisely. Reinforcement posts are installed to stabilize the structure. These vertical elements not only anchor the wall sections but also serve as future supports for coping and finishing materials. Their role is both structural and aesthetic. Hydraulic component installation follows. A PVC guide tube assists with the alignment and placement of the skimmer, which must lock securely into the pre-cut slot in the panel. Suction and return fittings are placed on the wall opposite the skimmer, ensuring proper hydraulic circulation. Each return housing is inserted from the front of the panel and fixed permanently in place. Next, an extruded female rail is mounted along the upper edge of the pool wall. This track will receive either a liner or a reinforced PVC membrane depending on the selected finish. For this installation, a reinforced membrane is used. Concrete is poured into the footbrace molds, starting from a corner of the pool. In locations where access is restricted, the concrete may need to be poured manually. These poured footings secure the panel base, increasing overall wall rigidity and anchoring the structure against lateral pressure. Before installing the waterproof membrane, the concrete slab is cleaned meticulously. Adhesive foam tape is applied over each panel junction to ensure a seamless transition and prevent visual or structural irregularities beneath the membrane. The reinforced membrane is then unrolled and positioned. This stage must be coordinated with the backfilling process, which involves placing and compacting earth behind the panels in controlled layers. Backfill stabilizes the wall panels and maintains membrane tension as it conforms to the interior surface. With all folds eliminated from the membrane and the pool bottom smoothed, the main drain plug is sealed. Flanging procedures then begin for skimmers, return inlets, and vacuum points. Sealing gaskets are applied, and fasteners are tightened in an alternating moderate torque sequence, ideally by hand, to prevent warping and ensure watertight performance. The skimmer flange is affixed at its four corners and then progressively tightened around its full circumference. The skimmer weir is inserted to complete this segment. For the return inlets, membrane punctures are made precisely at the screw points, and flanges are installed onto the return housings. Lastly, the filtration system is assembled. This includes connecting all piping to the pump, filter, and control units as provided in the kit. All connections are leak tested and pressure checked according to technical specifications. With assembly completed, the Parity Blue modular pool is now ready for operation. The system delivers structural strength, design flexibility, and long-term reliability, combining technical precision with elegant aesthetics.